with magnets. Now let us learn more about it. Discovery of magnetite. Magnet was not invented. It is said that magnets were discovered roughly 4,000 years ago after a shepherd named Magnus, who lived in Magnesia, Greece, accidentally got his iron tipstick stuck to a rock. It was later discovered that the said rock had magnetic properties and was called magnetite, an oxide of iron named so after the shepherd. What are magnets? Magnet is defined as a material, generally a metal, that can produce its own magnetic field. It attracts ferromagnetic materials like iron Fe, cobalt Co, and nickel Ni, and the alloys. Some alloys of rare earth metals like cerium Ce, erbium Er, thulium, Tm, etc. Compass needles, fridge magnets, and MRI scanners are some common examples of magnets. Rare earth metal is called rare as it is very unusual to find them in a pure form and is used to make powerful magnets used in computer memory, camera, loudspeaker, cell phone, etc. to enable them to be small and more efficient. Natural versus artificial. Temporary artificial magnets include electromagnet and metals such as paper clips that became magnets only when another magnet touches them. Permanent artificial magnets includes refrigerator magnets and neodymium magnets used in hard disk, mobile phone, etc. This to impressive amount of magnetic energy while being resistant to demagnetization. Artificial magnets are made by man by using different techniques. Natural magnets are found in nature. They are strong as compared to natural magnets. They are weaker as compared to artificial magnets. Artificial magnets can be temporary or permanent magnets. Natural magnets are always permanent magnets. Artificial magnets are available in different shapes and sizes. Natural magnets are available in the shapes and sizes as they occur in nature. Examples of artificial magnets are horseshoe magnet, bar magnet, etc. Examples of natural magnets are magnetite or lodestone. Magnetic versus non-magnetic. Magnetic materials. Materials which are attracted towards a magnet. Example, iron, cobalt, nickel, etc. Non-magnetic material. Materials which are not attracted towards a magnet. Example, glass, rubber, wood, paper, etc. Magnetic force. The force by means of which a magnet attracts objects towards itself. Magnetic field. Take some iron fillings and spread them on a table. Now bring a magnet close to them. What do you think can happen? We'll observe that the iron fillings will accumulate at the ends of the magnet. This is because the magnetic field of the magnet is very strong near the poles. A magnetic field is defined as the region around a magnet within which the magnetic force acts. Magnetic influence can pass through screens of some substances like cloth, plastic, paper, glass, etc. Magnetic poles. Every magnet is bipolar, that is, they have two poles at the extremities. The magnetic end pointing towards the north is called the north pole. The magnetic end pointing towards the south is called the south pole. Attraction between unlike poles. Opposite poles of two magnets attract each other. It is called attraction. Repulsion between like poles. Similar poles of two magnets repel each other. It is called repulsion. A freely suspended magnet always aligns in north-south direction. Travelers have used this property of magnets in navigating directions. Finding direction, magnetic compass. Earth has two geographic poles, north and south poles. Earth's magnetic poles are near, but not exactly in the same place as the geographic poles. A compass is a device with a magnetized needle pivoted inside a box covered by glass with directions marked on it. It is allowed to rotate freely so that when the compass is kept at the position of rest, the needle points towards the north and south direction. A magnetic compass aligns itself towards the magnetic north pole of the earth. Make your own magnet. Single touch method. When a magnet is rubbed rapidly on an iron object along its length, starting from one end to another in the same direction, the iron object gets magnetized as the particles inside the material align themselves like the poles of a magnet. Double touch method. When an iron bar or object is rubbed by two powerful bar magnets of equal strength with their opposite poles at the center, in opposite direction the bar or object becomes a magnet. Using electric current, the bar to be magnetized is placed inside the coils of a conductor and current is passed through these coils of wire. Demagnetization. A magnet may lose its magnetic property when it is harmed or hit, dropped with a force against a hard surface. Improper storage can also cause loss of magnetic properties. Bar magnets should be stored in pairs separated by a small block of wood and their unlike pole facing the same side with a soft iron across their ends. A piece of iron should be kept across the poles in case of a horseshoe magnet. Summarizing property of magnet. A magnet is bipolar, north pole and south pole. Like poles of two magnets repel each other. Unlike poles of two magnets attract each other. Magnetic forces are the strongest near the poles of a magnet. A freely suspended magnet will come to rest in the Earth's north-south direction. Few facts. The ore from which magnet is extracted is called magnetite. It is a natural magnet. Strongest natural magnet is lodestone or magnetite. Few microscopic facts about magnets. Each particle in a magnetic material behaves somewhat like a bar magnet. They are normally aligned randomly within the material, but under the influence of a stronger magnet, they realign themselves according to the stronger magnet's field. Magnets should be protected with keepers or should be kept in non-magnetic material, boxes like wood, cardboard, etc. Thank you. I hope you like this video.